This is the continuation, the part 2 of module number 17, and this is just, I want to go over a little bit of data that you would get if we did this lab, okay? There is an Explore Learning gizmo that I'm going to attach, and I've invited you in the classroom to go ahead and explore this one, and if you do, I'll post the solution set as well, and I'll show you what it looks like, okay? So the Explore Learning gizmo for this one is about chemical equations, and you can see here that you get to basically count up the number and type of the atoms on each side of a chemical equation, and you get to practice with that. There is another one as well for balancing chemical equations, and that'll be for next week's module. Okay, I'll note that there is a couple of things in here that lead us into grade 11 chemistry topic, but just do as little as much or as little as this one as you'd like to. Okay, so there's a gizmo that goes along with this. All right, back to here. We've established that in any chemical reaction that you have, we've got the same number and type of atom on the reactant side as we have on the product side, and so you can simply visualize this. If you can build some molecules, you can count up how many and what kind do you have. And that's where we realize that mass is really an indication of the number of molecules and the number of atoms that you have, right? Because if I were to add up the mass, and you could get that from the periodic table, all of the mass on one side is going to be equal to all of the mass on the other side. It just so happens for this reaction to take place, I actually need 1 molecule of methane, but I need 2 molecules of oxygen. And I've got enough atoms on that side for it to be able to make 2 molecules of water and 1 molecule of carbon dioxide. Mass can't be added or it can't be lost. And that's actually a law, okay? We know that to be a fact. So in any chemical reaction, matter just can't disappear. So if you were to do that in the lab, you'd be able to maybe have a test tube where all of your reactant, one of the reactants is in here, and the other reactant is in the Erlenmeyer flask. So can you see this? In this lab right here, we added cobalt 2 chloride, and we added it to sodium hydroxide, okay? The cobalt chloride is going to be in my little test tube, and it happens to be pink. It's a pink solution, okay? It's baby pink, it's transparent, it's a liquid. My sodium hydroxide, when you look at a solution of sodium hydroxide, how do I know these are solutions again? Because you can see that I've written that AQ right beside them. Okay, I would buy cobalt chloride in a container that's a solid. I add water to it. Water is nothing that's going to react with any of our products or anything of the reactants or the products. It's just simply going to dissolve the cobalt 2 chloride to make a solution. Okay, and that solution happens to be transparent. So all I'm going to do is put a little AQ behind it, and then I've added that to my Erlenmeyer flask that has some sodium hydroxide in it. Now, sodium hydroxide is transparent and it's liquid, but I just want to show you that that would be like, I've got 1 solution sitting in the bottom of my Erlenmeyer flask. I've got another solution sitting in my test tube, no reaction yet. If you take the total mass of this entire apparatus ahead of time, before the 2 reactants actually react together, then you could fill that in your table right here. Let's say I had 102 grams. Then I'm going to let those 2 actually react together. So how would you do that? Well, you put a stopper on it just in case any gases were formed. You don't want the gases to escape. And you could take a mass of your apparatus afterwards. Now, I know that there is a chemical change that's going to take place. You can see all the indicators of a chemical change. I'll actually post a demo video of this one. I'll just find one online and you can see what this reaction would look like. After it's done, we take a mass of the whole thing afterwards. Guess what? The mass is going to be. Is it going to go up? Is it going to go down or stay the same? It's going to stay the same. There's going to be no difference between the mass before and the mass after. Everything has been contained. Okay? Here's your chemical equation for this experiment right here. And what I want you to do is I'm going to get you to answer these questions with regards to this little lab activity. I think I'll be clear when I write out the instructions for this. But basically, we're just going to explain the law of conservation of mass, and it probably makes sense for us to just yeah, I think we'll just maybe do a few of these answers here, or you could do the Explore Learning Gizmo. Okay, that's the law of conservation of mass, and actually I think it's probably the most important concept from grade 10 science. Okay, we need to be able to understand this law so that we can do chemical equations where we look at ratios of how much product you get and how much reactant you have very specifically, because let's say we've got a reaction where we need to make some fertilizer that has some nitrogen in it. As a chemist, you want to make sure you don't waste any of the reactant. So you need how much reactant will you need to make a particular amount of product, okay? And so that's the kind of math that we'll do in grade 11 chemistry, but it's all based on understanding the law of conservation of mass, that no atoms are created or destroyed, they're simply rearranged. So the bonds inside the reactants break, atoms rearrange, and new bonds between the atoms form to make new products or new molecules. Those are the products. Okay, so that's it for this module. I hope everything's going well, and we'll talk to you next time.